good evening, everyone. Myself, Suresh Gurjar. I'm working with the PowerTech consultants, and today I'll be giving a presentation on a training program for the energy audit for the DISCOM company. So I'll be sharing my screen now. Is my screen visible?
Yeah, visible.
Yeah, thank you. So we can start with it.
Carry on.
Yeah, thank you. So basically, it's a training session for conducting energy audit of a distribution company. So it's a brief about PowerTech consultants. We are a consulting house in the field of power, energy, and project management. We take up the following projects like project management consultancy, consultancy on regulatory, MNV audit, mandatory energy audit, and preparation of DPR for the power projects. So these are the clients of PowerTech consultants. So what is the basic input and output of an energy audit? So input would be the collection of the DISCOM network system details, and the categorize what are the number of the consumers, their annual energy consumption details, and the connections and disconnections, what is the connected load, and how much energy is billed for individual category wise what consumers, and then the measurements at the feeder substations for the feeders and the substations, and data sheets of the transformers and the logbooks. So output of all this collection would be to give up a overall picture of a DISCOM. What are the transmission, how much is the transmission distribution loss, what are the AT&C losses at each feeder. So that will give us an idea about where the maximum losses are happening, and that will give a company also a idea where to focus on for the energy efficiency and improvement, and also for the reduction in the overall transmission and distribution loss. So this is a basic questionnaire that is given to a DISCOM company before any energy audit, so that we get the data from them, like what are the details of the head of the DISCOM, their designations, and then the details like single line diagram of a distribution network, what are the assets of the DISCOM, consumer details, supply areas, and also the category wise the details of the consumers, and what is their energy consumption, and details regarding the number of connections, number of disconnections, what is the connected load, what is the percent of the total connected load, how much energy is billed, and then also at the same time what is the total supply hour and scheduled outage, and if any scheduled power outage is there, those details need to be collected. Similarly, the details of the feeders also need to be collected. And then what are the meter so we'll discuss how these calculations losses are being calculated based on the collected data in the later slide. And then we also calculate the average billing rate, or category wise average billing rate is nothing but the total bill, how much is being billed for all categories, then divided by the what is the total unit billed. So that will give you the billing rate. And then collection of the data regarding the system improvement and also loss reduction, So those all these will be like put up in the report, final report. So this is a questionnaire for the field measurement of DISCOM. What basically is to be done in the field measurement is we go there and like we take up the note down the grid name from where the 33 kV, what are the feeders name, and the measurements of the voltage, current, power factor, power, the 33 kV input in the grid, what is the conductor size, what is the pole type, what is the span length, sag. So these will be like we'll be discussing the net letter slider also. What is like what we mean by span length, what is meant by sag, uh, and that this measurement is at 33 kV input. Then 33 kV receiving end of the in the grid. Then like that 33 kV like it is stepped down to 11 kV with the transformer, and then the measurement at the outgoing from the transformer, and then at individual 11 kV individual outgoing from the transformer also calculated. So these all details need to be collected when we go for the field visits. And at the same time, when we are collecting the readings, we also have to keep a check on whether the 33 kV incoming feeder voltmeter is working or not, because these ratings, these readings are very crucial to give an overall picture of the how energy flow is happening in a total DISCOM network. And similarly, ammeter is working or not, and what is the meter reading of the peak time, whether substation, every instrument is working or not, like isolators, whether they are in working condition or not, thermograph check of the both the bus bar and there is any heating point, like localized heating is happening or not. So that will give a like idea whether like instrument any damage is happening or not. So next, like we'll take up the feeder names and their meter readings at the individual feeders, and then verification of the records, register of the meter complaints, and meter calibration is done or not. And also like power transfer, what is the condition of the power transfer, whether there is a leakage or insulation is proper or not. So all these observations would be very crucial for the like to give an overall picture of the DISCOM network. So next. Similarly, once the 33 kV is done, we will next go to the 11 kV feeder line. There also like what are the consumers list, what is their category, because for every category the tariff is different. So though all the category wise the feeder consumer list has to be maintained. Then to identify the power transformer loss, the measurement at the 33 kV and 11 kV outgoing side will be measured. So next, power measurements of each distribution transformer in an individual feeder is also calculated. Then finding of the metered and unmetered consumer list in respective feeders. And so after collecting this, we calculate the technical losses, TND losses, commercial losses, AT&C losses, and the each identified feeder, and list out the default consumer list in the also in the respective feeder. So now I'll give a brief at a background study, like technical detail, what exactly are the what are the technical theory behind the calculations. So this is a basic of diagram for an electrical distribution system, where you can see the energy is being generated at power station at 11 kV. Then it is stepped up using a power transformer to a higher voltage. The advantage of transmitting the power at higher voltage is that the loss would be less, because I would be less, I square losses, and also at the same time, like when I is less, conductor size also like would be less. Therefore, that's the reason why we transfer the power at a very high voltages when it has to be transferred at a long distances. So once it is transferred, then it comes to the transmission substation where it is stepped down to a lower voltage, like from the to 33 kV. Then from 33 kV to it is stepped down to 11 kV. So if a consumer is there at a 33 kV, that would be 33 kV primary consumer. Then when it is stepped down to 11 kV, then like we have 11 kV feeders. Uh, from 11 kV feeders, then like it reaches to our locality, like for local distribution. There it is stepped down to 415 volt. So if any from there 415, like it can be given to the distribution to consumers, distribution consumers. So this is a like a line diagram of the same thing which I have shown in the previous slide. AC generation at 11 kV, step up to 11 kV to 220 kV, higher voltage. Then like it is like it is transmitted for long distance. Then like it is stepped down to lower voltage from 220 kV to 33 kV. Here, like you can have the 33 kV primary distributors. Then like we go for 33 kV to 11 kV step down, and then we can see the high HT consumers. They are all 11 kV consumers, and then finally to the secondary distribution to the lower LT distributors. That is at 415 voltage. So these are the basic types of the electric poles. The first one is like we have a steel pole which you have seen in your locality also, which is three phase. The top wire is a neutral. Here all the three phases are there, and the second one is RCC. This is cemented one, and the third figure is pre-stress cement concrete pole. This is single pole with the V cross arm, and the second figure is a double circuit. There are two circuits, three at the bottom RYB, and then at the top it's a neutral. So two circuits are the same pole, double circuit pole. And this is about like what exactly we mean by span and sag in a transmission pole. These are two poles, and this is a conductor. The distance between two poles is a span distance, and the distance at the top from the top to lowest point of the conductor is sag. At the bottom one is the clearance, ground clearance. So different types of the conductor that are used in transmission lines. Earlier copper was used, but now we like aluminum and its alloy is being used. The main advantage of using aluminum is that it's lighter in weight and also cheaper in cost compared to the copper conductor for the same resistance. And these are the four types of the aluminum conductor. AAC, it's all aluminum conductor. Triple AC, all aluminum alloy conductor. ACSR, aluminum conductor, steel reinforced. You can see the cross-sectional view of the ACSR. In the middle, it's a steel, which is to give a strong mechanical strength to the conductor. And at the at the outer side, it's all aluminum. So these aluminum wires, they are twisted to give a good tensile strength. So now, how to calculate the transmission distribution losses? Energy, like when it's getting transmitted from one pole to another pole, there will be definitely loss in the conductor, and when like it goes gets stepped up or stepped down, there will be losses in transformer also. So all those losses, they need to be calculated. So how we are doing, like energy losses mainly occur due to technical and commercial reason. The technical are due to the energy which is being dissipated in the conductors or transformers or any other equipment that is being used for transmission of the power. Now then the commercial, there's another component. This is called commercial losses. This is due to pilferage or by the hooking, like you see in the distributions LT at the lower tension, lower voltage. People like they put up the hook to get the power, and they don't pay for it. So that would be like it would result in a loss to the company. So or others like few people, they bypass the meter which has been installed by the distribution company. So that also, since it's not being accounted, it gets into the loss account. And similarly, if there is a defective meter or error in meter reading, or if you're wrongly estimating the unmetered supply of the energy, these all are the main sources for the commercial losses. These two losses, technical losses and commercial losses, when we add up, that gives us the transmission and distribution loss. Now, there is another component to commercial loss, which is attributed to the non-recovery of billed amount. The billed amount, the company has billed it but could not recover. So that gets reflected in the collection efficiency. When this component, when added to the T&D losses, would give us aggregate technical and commercial losses. Now, since these are the formulas, it's very simple. T&D losses, I said, total energy bill by total input energy in the system. So it's energy billed by 1 minus total energy bill by total input energy. So in the numerator, if you simplify it, it would be total energy input minus total bill by total energy input into 100. Now that is T&D losses. Now since I told there's also another component which is attributed to the collection efficiency, that when get added to T&D loss would give us AT&C loss. So it's a very simple, like 1 minus billing efficiency into collection efficiency. Billing efficiency, same as what I told, total energy billed by total input energy. Collection efficiency, revenue collected by total amount billed. So like collection efficiency, like suppose X amount was billed, but we got Y only. Revenue collected was Y. So the collection efficiency would be Y by X. Now, what are the guidelines for the conduct of the energy audit in the electricity distribution company? This is by BE notification, which was notified in October 2021. I'll be listing down, discussing few important points of this notification. So in that notification, it has been clearly mentioned that every electricity distribution company has to conduct an annual energy audit every financial year, and also a periodic quarterly energy audit by energy manager of the company, and that has to be submitted to bureau and the respective SDA. What exactly is meant by energy accounting is to account all the energy flow, what is inflow at the various voltage level, at 33 kV, 11 kV, and also at the LT level, in the distribution periphery of the network, including the renewable energy generation, open access consumers, and energy consumption by the end consumers. So these are the prerequisites for an energy annual energy audit. Identification, these are which we discussed in our questionnaire. It's almost the same. This is to map all the electrical network assets and also the high tension, what are the high tension and low tension consumers. And this is also important, like each DISCOM has to develop and implement an information technology enabled energy accounting and audit system, so that there is in fact no like manual collection or manual interference. And then every DISCOM shall ensure that there is installation of functional meter at all the consumers, transformers, feeders in a phase-wise manner within a period of 3 financial years from the notification of this regulation. And so this distribution transformers, they should be metered, and they should be communicable with the communicable meters, so that they get the reading automatically with the system that like what IT system they have enabled. And non-existing communicable, they has to be replaced by communicable meter and integrated with AMI, automatic metering infrastructure. AMI stands for automatic metering infrastructure. So as I discussed, like information technology, it's an enabled system so that there is very like least manual interference, and then uh, every electricity distribution company has to create a centralized energy accounting and audit cell, which should be comprising of the nodal officer, an energy manager, and an IT manager. Information about the what is the feeder name and details and consumer details. So this I have discussed this, like this would ensure that the data which the DISCOM is collecting, it should be from the metering system, and in case till the time it's not there, an agreed method of assumption shall be prescribed by the state commission. And for metering of the distribution transformer at high voltage distribution system up to 25 kVA can be done on the cluster meter basis, which is installed by each electricity distribution company. And this energy accounting and audit system and software shall be developed in such a way that it creates a monthly and a quarterly and yearly energy accounting report. So manner the same which we discussed in our questionnaire. What is the energy flow between the transmission and 33 kV and 11 kV incoming? So these are at all different voltage level. What is the energy flow? That has to be like verified and calculated, collected from the DISCOM. And then the data that we have received, it should be analyzed and processed with respect to consistency of the data monitoring, and also the final report should give a recommendation so that they can improve in the energy efficiency side, and also reducing the losses in the electricity distribution company. So the metering timeline, the notification, they've given the timeline for metering: 100% communicable feeder metering integrated with AMI by 31st December 2022. And all distribution transformers other than HVDC up to 25 kVA and shall be metered with the communicable meter. These are these are categories which should be done by December 2025. And for other case like prepaid smart consumer metering to be completed by all directly connected meters and AMR in case of other meters by December 2023. The categories are the same as listed above. These categories. All electricity division of 500 Amrit cities. So these need to be completed by December 2023. And in rural or the hilly areas where connectivity and communication is an issue, there prepaid meters may be opted. These are the target for consumer metering: 98% by fiscal year of 2022-23, 99% by fiscal year 2023-24. These are the targets for the functional meters. So by 2024 to 25, consumer metering target should be 98%. And distribution transformer metering 98%, feeder metering it's almost like 99 plus 99.5%. So this is will collect the data from DISCOM for all feeders, but to have an verification, we'll be doing for 2 feeders. The physical visit will collect all the data like meter readings, the voltage, current, power factor, power, and the observations like insulators are working out, transformer is in good condition or not. So those would be done for 2 feeders. So we collect the data, we go to the visit, we collect the data readings, we take up the readings, monthly readings, and then we put it into this this table. So what basically is this table? I'll discuss. So first the grid name, from where the OPTCL grid name, from where the 33 kV supply is being procured. The 33 kV feeder names, what are the feeder names? Then what is the length, the circuit kilometer length, the electrical length of the feeder? The total input in million units, that is the input from the grid, the OPTCL grid. What is the input? Total input A. Then what is the consumption by 33 kV consumer, if any? Suppose there is a primary consumer of 33 kV. If there is a consumption, we list into here. That is B. And then the name of the 33 by 11 kV substation. Here there will be power transformer, which will be stepping down the voltage from 33 to 11 kV. What is the input to 33 this substation? And then what are the feeder 11 kV feeder from that substation? What is the input in the 11 kV feeder? So that would give us this will help us. This is after the transformer. So to get to calculate the what is the 33 kV transmission loss and the power transformer, what is the power transformer loss, you have to subtract from the input energy A minus the total of this total input, the sum of the total 33 kV consumer and 11 kV feeder. So I hope it's clear. It is input from 33 kV is A, the input from the grid is A, then it come up to this substation 33 by 11 kV, and in between if there is 33 kV feeder, that calculation can be listed in B, this column, which would be B, the value of B. This B would be added to all the 11 kV feeders. What is the 11 kV feeders consumption? When that get added, that will give us the total 33 kV consumer plus 11 kV feeder consumption. Loss, it's this value minus the input value, D minus A. And the loss percent E, the loss in MU divided by the input in MU into 100. The average, what is the average loss which has been observed during the last quarter? This is for 33 kV energy audit. Now we'll go for 11 kV. Now we'll come to the 11 kV feeders. Name of the distribution division, name of the 11 kV feeder, what's the code, length of the feeder in kilometer. Now how many distribution transformer are there in that line network, and what is the total capacity of the distribution transformer, and how many consumers. So here the readings of the meter need to be taken. To get the input value, if you subtract from the present reading to the previous reading, multiply by multiplying factor, you get the input to the feeder. And this is the billing to a high tension consumer. How much energy has been billed to high tension consumer? Billing to LT consumer. The total of these two columns would be total unit billed in MU. The loss would be input minus the bill one, and the loss percentage. Similarly, it's similar to the previous slide itself. Input, the loss would be like input minus output by input percent into 100. So now this is for the calculation of average T&D loss of a distribution transformer for a quarter, that is for 3 months. 11 kV feeder, what is the name of the 11 kV feeder? The feeder manager, the name of distribution transformer, DTR code, the capacity of the transformer KVA. Now how many consumers are there under that distribution transformer, and the number of the months taken for average calculation. Here it is, since it's a quarter, so 3 months. Total units advanced, what is the input unit, the total unit billed, the loss would be the subtraction of this total unit and total unit billed, and then similar then you can calculate the loss percentage, T&D loss. And then the average, it can be compared with the previous quarter. And this is the last column is the distribution transformer loading in percent. So this is just a breakup of the previous table. 33 kV feeder line. What is the energy consumed at 33 kV grid end? That is at the OPTCL grid. And then incoming transformer, what are feeder 1, feeder 2, feeder 3, the meter readings. So that would be added up. Similarly for transformer 2. So that's a breakup of the previous table. This is also similar to the previous slide, like the breakup of the feeder lines from 33 to 11 kV. So this is a few sample shots, snapshots that we have taken during the previous visit. So we go to the DISCOM substation, we discuss it with the engineer there, and then the transformer readings in the second slide, you can see the transformer readings are taken. And similarly, the energy meter reading and the voltage and current and power factor on the logbook. So also at the time of the visit, like you have to check up whether proper earthing is there or not. And other safety precautions are taken or not. So that's the end of the slide.